Hello students. The last class we are discussing about the meaning of potential difference and the relation between intensity of current, charge and time. You know, the potential difference is the work done in moving a charge from one point to the other. That is, the potential difference is equal to the work done. That is W. If W is the work done to move 1 coulomb of charge from one point to the another, then that work done is equal to the potential difference between these 2 points. That is, W is equal to V joules. Again, if W is the work required to move 1 coulomb of charge from one point to the other, then the potential difference between these 2 points is equal to the work done. That is why we say that, please look at the board, we can say that W is equal to V joules. You know, potential difference is equal to the work done to move 1 coulomb of charge from one point to the other. Here W is the work done, and to move 1 coulomb of charge from one point to the other. Therefore, the potential difference between the two is V joules. You know, joule is the unit of work and voltage is the potential unit of potential difference. Therefore, now we know that W is equal to V joules. Then here the work done to move 1 coulomb of charge from one point to the other is V joules. Then the question is that if it is so, what is the work done to move Q coulomb of charge? You know, coulomb is the unit of charge. What's the work done to move Q coulomb of charge? The work done to move 1 coulomb of charge is V joules. Then the work done to move Q coulomb of charge from one point to the other is W is equal to Q into V. Okay. Then to move this charge from one point to the other, the work is to be done. That work is done by the cell or battery connected to the circuit. Okay, that is, to do the work, we know that energy is required. Then energy required, the work required to move the charge from one point to the other is supplied by that cell or battery connected to the circuit. Clear? Therefore, this energy or supplied in unit time or work done in unit time, you already studied 9th standard. That is what is called power. That is, energy supplied by this cell is the power of that cell. You already studied the power in 9th standard. You know, power is the what? What is the power? Power is the work done in unit time or energy consumed in unit time or energy supplied in unit time or liberated in unit time is the power of a cell, is the power. Am I right? Therefore, here power P, and you know the work is W, denoted by the letter W, and time to do that work is T. If W is the work and time is T is the time of doing work, then power P is equal to W by T. That you already studied in 9th standard. That is power is equal to the work done in unit time. That is W by T. Now we can rewrite this equation. P is equal to W is equal to Q into V, that is equation number 1, into how P is equal to V into Q by T. Okay, because P is equal to W by T. Okay, then instead of W we can write what? Q into V. Therefore P is equal to Q into V by T. In this equation, P power P, in the equation power P, you know, power is equal, P is equal to W by T. Instead of W, we can write what? Q into V, or V into Q. Therefore, P is equal to what? P is equal to what? V into Q by T. But in the earlier class, in the previous class, you studied that Q by T is equal to I is equal to Q by T. Therefore, instead of Q by T, we can write what? I. Therefore, P is equal to VI. Okay, then this is the power supplied. Then energy supplied, if it is so, this is the power supplied in 1 second. This is the power supplied in 1 second, or energy supplied in 1 second. Then what is the energy supplied in T second? That is P into T. You know the power is the energy supplied in 1 second. Then what is the energy supplied in T second or 10 second? The energy supplied in 1 second into 10. Just like that, if the energy supplied in T second is equal to, which is equal to P into T. Then in the first equation, you know that here you know that P is equal to V into I. Right? Here P is equal to V into I. Therefore, we can write this equation as instead of P we can write VI. Then instead of P we can write VI. Then this is equal to what? Energy supplied in T second is equal to VIT. Okay. Then this is the energy supplied in T second. Therefore, W is equal to VIT. Energy supplied in T second is this energy supplied is used to do the work. This energy supplied is used to do the work. Therefore, the work done, W is equal to VIT. Then, while doing this work, electrical energy is converted into heat energy, or the energy supplied by the cell or battery is converted into heat energy. Therefore, work done is equal to heat energy generated. Therefore, we can write W is equal to H. Therefore, we can rewrite the equation into H is equal to VIT, with H is equal to VIT. Now, we can arrive at a conclusion that when electrical energy passes through the conductor, how the heat energy is generated. That is here this nichrome wire. Our question is that how do the nichrome wire convert electrical energy into heat energy? Am I right? Therefore, here we can arrive the conclusion that the energy supplied by the cell, the work done is supplied by the cell is converted into heat energy. Am I right? The energy supplied by cell is used to perform the work. During this work, the energy is converted into heat energy. Energy supplied by the cell is used to perform the work. During this work, electrical energy is converted into heat energy. Yes, now we reach our answer. We got the answer. Why do the nichrome wire convert, or how do the nichrome wire convert electrical energy into heat energy? The energy supplied by the cell is used to perform the work. While doing the work, during the work, electrical energy is converted into heat energy. Clear? Yes. Now I hope you remember the animation that we shown in the last class. That is by using an aluminum wire, a nichrome wire, and a 6-volt battery and a switch. In that circuit, here this aluminum wire, nichrome wire, and the 6-volt battery and switch are connected in series. When we switch on the circuit, what happened? The nichrome wire alone becoming red hot. Am I right? This current, this cell supplies the energy through this circuit. Both this nichrome wire and aluminum wire got current, got electrical energy. But even though this the electrical energy flow through the nichrome wire and aluminum wire, the nichrome wire alone becoming red hot. Am I right? Then our next question is that why the nichrome wire, why did the nichrome wire in the circuit alone becoming red hot? Am I right? That we can discuss in the next class. Okay, thank you.